All right, welcome to the first test of the 2018 Math Open. Here's the explanation video. So the first question asks, a student who focuses on STEM subjects earns about $20,000 more annually on average than someone who focuses on non-STEM areas. Over a 40-year career, how much more will the STEM person earn? So let's think about this for a second. We know that the STEM person will earn about $20,000 more a year, and we know that they'll do that for about 40 years. If we multiply those two numbers together, you get 800,000. And that's your answer to the first question, $800,000. And just so you know, these are actual numbers, or pretty close to actual numbers. Studying STEM will lead to substantially higher income if that's what's important to you. Question number 2. My older son, Adam, just turned 7 years old. How many seconds old is he? All right, so let's think about this. He's 7 years old, and we need to go from 7 years to seconds. How can we do that? Well, how can we break down years? We can break down years into days. There are 365 days in a year. And notice here, there's a year here and a year here. You're going to see that again. So now we have days. We can break that down to hours. There are 24 hours in a day. Notice again, we have days here and days here, just like we have years here and years here. So what do you think our next one should be? There are 24 hours in a day. There are 60 minutes in an hour. Again, look, hours here and hours here. And there are 60 seconds in a minute. So we have 7 years, 365 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. If you multiply all those together, 7 times 365 times 24 times 60 times 60, you get 220,752,000 seconds. That's how old Adam is. And for those of you who are a little bit of a stickler, which makes me proud, it's actually a little bit more because there are leap years. So Adam, if you added 2 extra days to that, you'd get a little over this answer, but we gave credit for 220,752,000, or a little bit over if you counted for leap days. Question number 3, this is geometry. The volume of a cube equals volume times height times width times length. You have a bucket that is 14 inches high, 10 inches wide, and 12 inches long. And you have a smaller cup that is 4 inches high, 3 inches wide, and 3 inches long. How many of the smaller cups would it take to fill the big bucket? All right, so let's look at what we have. We have a big bucket and a small cup, and they're both cubic, so they both have the same volume equation. Now we can figure out the volume for the big bucket by looking at its height, width, and length, which is 14, 10, and 12. We can multiply those together, and the big bucket has a volume of 1,680. We can do that same thing for the small cup. It has a height, width, and length of 4, 3, and 3. Multiply those together, and it has a volume of 36. So how many of the smaller cups does it take to fill the big bucket? That becomes a pretty simple division problem. 1,680 divided by 36 is 46.7, and that was your answer. Good job. This geometry question is probably something you would start to learn in maybe 8th grade, maybe 9th grade, so this is not an easy problem. Question number 4. I want you all to be healthy and have strong bones. A 10-year-old needs about 1.3 grams of calcium per day, and a cup of milk has about 0.3 grams of calcium. How many gallons of milk would a 10-year-old need to drink in a year to get all her calcium? And just so you know, there are 16 cups in a gallon. All right, so this is really asking 2 questions that we need to figure out. How much milk do you need in a year? And how much calcium is in a gallon of milk? So let's do the first question first. How much milk do you need in a year? Well, you need 1.3 grams per day, and there are 365 days in a year. Just so you know, notice that we have the same thing where days are here and days are here. Whenever you do problems like that, you typically want to make sure your units are matching because that will make sure the problem works. So now we can take 1.3 grams per day times 365 days per year, and that tells us that a kid needs 475 grams of milk in a year. I'm sorry, grams of calcium in a year. Now, how much calcium is in a gallon of milk? We know there are 0.3 grams of calcium in a cup, and we know there are 16 cups in a gallon. Again, notice these units are matching. That's very important. We can multiply that out. 0.3 times 16 equals 4.8 grams. So every gallon of milk has 4.8 grams of calcium. Well, now we can divide those, and we know that a kid needs 475 grams of calcium in a year, and you can get 4.8 grams of calcium from a gallon of milk. So that means you need 99 gallons of milk in a year. I strongly suggest you do not drink that all at once. Question number 5. This is a compound interest question, and this is so important. I promise you, you will see one of these on every single test we have. So get good at this. And if you get good at this, financial freedom and being rich, if that's what's important to you, becomes a lot easier. Pete, my younger son, invests $800 at 7% interest. At the end of 35 years, how much money will he have? Well, this is the formula for compound interest, and I really want you guys to memorize it because it's so important. You take what you're starting with, you multiply that by 1 plus your interest rate, you raise that using exponents to the number of years, and that will give you what you end with. Just to make it in variables, we're going to say S times 1 plus R raised to the Y equals E. Now let's figure out what we know and what we don't know. We know that Pete is starting with $800. He has an interest rate of 7%, and he's going to have 35 years to do this in. So the thing we don't know is our E. So let's figure out our E using this formula. There's the formula again. S times 1 plus R raised to the Y equals E. And then we can just fill in the things we know. So we know S equals 800. We know R equals 7% or 0.7. And we know Y equals 35. And then if with all these, we have all numbers here now. We know there isn't anything we don't know on this side of the equation. We can get E. If you put that into your calculator, you get 1.07 raised to the 35. Remember, the raised to the 35 is the y to the x button. So type in 1.07 y to the x 35 equals times 800 equals $8,541. So your answer is $8,541. So Pete starts with $800, and in 35 years, he gets over $8,500. Two really important things. A, that is the power of compound interest. Pete basically exchanged every dollar bill for a $10 bill by doing this. That's pretty darn good. B, compound interest and compound exponents is so important. We are going to see this on every single test. So I really want you guys to look at this problem and get good at it. If you need more practice, every single test we've done on this uses this. So you can have all sorts of practice if you want. And here's the last question. This is a probability question. Probability is another really important mathematical skill. So I want you guys to get good at this too. I have 20 songs on my old school metal playlist, 9 of which are Black Sabbath. If I put it on shuffle, what is the probability of it starting with 2 Black Sabbath songs in a row? All right, let's try to visualize this. You can imagine I have 20 songs, 9 of which are Black Sabbath. So maybe it could look something like that. And with the first song, what we want to do, we want to understand what's the probability of the first 2 songs being Black Sabbath. Well, for the first 2 songs to be Black Sabbath, the first song has to be Black Sabbath. So what's the probability of the first song being Black Sabbath? So you can see there, we circled a Black Sabbath song. There are 9 Black Sabbath songs out of a total of 20. So the probability is 9 over 20, or if you like percentages, 45%. Now this is where it gets a little tricky. What's the probability of the second song being Black Sabbath? Well, first of all, remember, we've already played 1 Black Sabbath song, so that changes it a little bit. Now, there are 8 Black Sabbath songs. Remember, this Black Sabbath song is gone now because we already played it. So there are only 8. 1, 2, 3, 4, 5, 6, 7, 8. And there are a total of 19 songs, because remember, this song went away. So instead of having 20 total songs, there are 19 total songs. That's the hard part about this. That's the tricky part. So the probability of the second song being Black Sabbath is 8 out of 19, which you can do a percentage is 42%. Now you can put those together, and what's the probability of the first song and the second song being Black Sabbath? You just multiply those together, 9 over 20 times 8 over 19. And that gives you 72 over 380, which gives you 18.9%. And that's your answer, 18.9%. If you got this, this was a very hard question, so congratulations. If you didn't, hopefully this shows that while probability might seem hard at first, you really understand it. You could figure out the probability of that first song being Black Sabbath, no problem. And you could figure out the second song if you knew the trick. Get good at this, because man, if you can get good at this, there's nothing stopping you. So there we go. That's the first test. Congratulations. And like I say every single time, these are not easy tests. If you're sitting down as a 4th or 5th grader taking this test, this is what 8th, 9th, 10th, even college kids, there's subject material in here that they take. So just taking it and sitting down through it is a huge accomplishment. If you get a couple right, even better. So I hope you had a great time. Special thanks to Congressman Mark Walker for joining us. I hope that was fun. And we will see everybody on the next test on November 19th at McNair Elementary School at 3:15 p.m. Until then.